talk about the difference between a histogram and a bar graph. So we're going to start with a bar graph because that's something that we've typically seen before. We've probably used it before in our STEM fair projects or wherever else. So if you can see here, a bar graph, they have equal spacing. So there's a space between each bar. And then on the y-axis, again, the y meaning this axis right here, which is number of girls in the class. On the y-axis, we have the numbers, and on the x-axis here, we have data, which can be anything. So in this case, it's categories. So it shows us that in class 5, we have 30 girls. In class 6, we have 35 girls. In class 7, we have 20 girls. So this is showing us more so categorical data, right? So then let's compare it to a histogram. A histogram, the bars are fixed. So that means that there's no spacing. Just in a bar graph, there was spacing. In a histogram, there isn't. On the y-axis, again, this is showing us number of students. We have numbers. And on the x-axis, we have data, which is continuous and will always be a number. So again, in a bar graph, this was categorical. If you were doing a STEM fair project and you were comparing the growth of a plant that listened to music, a plant that got sunlight, a plant that got more water or less water, that would be represented in a bar graph because those are categories. But if you had continuous data, just like this, so this says marks obtained. So basically this is like saying if we took a quiz and the quiz was out of 30 points, and this is all the students in the class and how they did on the quiz. So you can get between 0 and 30 points. That's why it's continuous like this. So this shows us that right here, kids that scored between 0 and 5 points, that was 2 of them. Then there were another 2 students that scored between 5 and 10. But then between 10 and 15 points, there were 5 students. So again, we had 2 students score between 0 and 5, 2 score between 5 and 10. Then we had 5 students score between 10 and 15 points. Another 5 students score between 15 and 20 points. Then we had 3 students score between 20 and 25, and another 3 students score between 25 and 30. So if we added these up, this would tell us how many students took the test or were in the class. So we have, this is 9, and then this is 11. So we have 20 students in the class, But again, we wouldn't show this necessarily with categorical data because it's a like running scale. You can tell that this group scored between 0 and 5, this group between 5 and 10. So it's all part of the same trend line. The next type of data graphing tool we're going to talk about is a pictograph. Again, display of data represented by pictures. Each picture can represent a certain number of units, and usually you're given what we call a key. So here our key tells us that 1 bag of Lay's equals 10 items sold. Then 1 chocolate chip equals 10 items sold, and then 1 lollipop equals 10 items sold. So again, that means each of these is 10 items sold. Right here, 10, 10, 10, 10. This is only half, so I know that half of 10 is 5. Same thing with this, with the chocolate. This is 10, 10, 10, and then half of a chocolate chip would indicate 5. So it's a pretty easy way of graphing the data in a picture form. So we can tell that the chips sold were 10, 20, 30, 40, 50, 55. So 55 items that were chips were sold. Then we look at our chocolate, we have 35 sold. Then we look at our candy, each of these is 10. So that means we had 40 items sold. So again, looks like we're doing the best with chips, maybe not doing as well with chocolate, and maybe there's a reason for that. So again, data is meant to inform decisions like we talked about last week. Okay, the next graph that we're going to talk about is a scatter plot. Again, like I mentioned earlier in the class, each of these points represents a person. Each data point is a person. This shows us a trend, and we're going to talk about positive versus negative trends and strong versus weak trends. So right now, I'm going to tell you that this is a positive, strong trend. So how can I tell that it's a positive trend? It's going up. So again, if as you're increasing in weight, you're also increasing in height. So again, these people right here that are a lot heavier are also a lot taller. So this is a positive trend, positive trend. It's also a strong trend because each of the data points or each person is very close to the other people. So if the data was spread out, like kind of like this would show a weak trend because there really isn't a trend at all. This shows us that majority of people are around the same kind of trend line. This right here with the weak trend doesn't actually have a trend line. We really couldn't tell where the trend was, right? So again, this is a positive, strong trend. Again, it tells us that as people weigh more, they are also higher in height. So you can see the people that weigh the least are the shortest. The people that weigh the most are the tallest. And that makes sense because as you kind of grow taller, your weight spreads out. So you end up potentially weighing a little more.